Now here I will start with this case 1. Case 1. In the case 1, we will consider the 10 volt source. We will consider 10 volt source. And remaining sources are replaced by the respective internal resistances. Remaining sources are replaced by respective internal resistances. This is right. How will be the figure? I am using the reduction technique here. There are the number of ways which we can use. Here I am using the reduction. जब भी simple problem होगा, reduction technique will be the best option. Here हम इसका reduction करेंगे. We will reduce this figure. This is minus J4. This is plus J3. Otherwise, if we are using the matrix, इसको matrix में करेंगे तो complex calculations बहुत ज़्यादा हो. Because the calculator does not support for the complex calculations solving of the equations. That's why it becomes difficult. इसलिए इसकी reduction method ही अच्छा है. Then 0 degree. First, we will reduce this figure for case 1. Case 1 के लिए next figure क्या होगा? ये दोनों parallel combination में होंगे. This next figure will be something like this. This is plus. This is 10 at an angle of 0 degree. ये 10 ohm as it is रहेगा, and here will be its parallel combination. Parallel combination जब भी होगा हम इसको कहते हैं impedance ZP. I will call it as ZP. That is parallel combination. ये दोनों का. How much is this value of ZP? Multiplication of these two divided by summation of these two. It's minus J4 into J3 divided by plus J3 minus J4. This is right. Find out those calculations. Now shift the calculator in the complex domain. Mode complex is the 2 and use the calculator. I will use a bracket. Minus J4 means 4i. Minus 4i close the bracket into this value. Start bracket. 3i. I will close the bracket. This is right. Divided by. This is divided by this bracket. How much is the value? 3i. Is it right? Minus 4i. Close the bracket. Put is equal to 0. We will get its. Look at here. How much is the value I am getting? 12i. This here plus J12 is the value. Is it right? Otherwise, I will show the calculation. Oral calculations also we can. J into J, which is J square, is a minus 1. This minus into this minus, that will be the plus. This is right. And 4 into 3. 4 3s are, it will be 12. 4 3s are 12. Is it right? This is J3 minus J4 will be minus J1, and if we are shifting the J in the numerator, its polarity will change. It will become J12, which is same as this. Otherwise, better way, use the calculator. This is right. Now, in this case, in which current we are interested? We are interested in this total current. इसी current में हमारा interest है. For first case, I will name it as IL1. Same current. How much is this value? 10. This here, first case IL1 is equal to, how much is the value? Total voltage. 10 angle 0 divided by, this is J12. This is J12 and this is 10. This total value will be 10 plus J12. This is very same as 10 plus J0 divided by 10 plus J12. Find out this value, that will give the current. That will give the current. In this case, if we are calculating its value, then look at how will be the value. I will use the start bracket. 10 plus 0 I, otherwise लेने की जरूरत भी नहीं है, divided by 10 plus j12. This is 10 plus 12 I. 10 plus 12 I close the bracket is equal to. This is the real part. This is real part. How much is the real part? 0.41. 0.41 is the real part. And how is the complex calculation? If the complex calculation कैसे होता है second step? I'm not able to recall. Can anybody is able to recall what is the next procedure in the calculator? Calculator में अगला वाला step क्या होता है? How is the next stage? Yes, anyone? What is the next step? I guess shift this. Yes. It is minus j 0.49. 0.49 is the load current for case 1. Now case 2. Now consider the case 2, and in case 2 we will consider this phi angle 90 source. We will consider phi angle 90 degree old source, and remaining all sources are replaced by respective internal resistances. This is right. In that case, its figure will be something like this. This will be replaced by its internal resistance. It is a voltage source. It will be replaced by 0. Here is one source. This is the capacitor. This is the inductor. And here will be the source with this polarity. 5 angle 90 degree. If it is not given, you can assume any polarity. Generally, polarity is given. In case of the AC, plus J2. This is on. This is also on. This is minus J4 on. Here it is 10 ohm. And in this case, we are interested in this current. Find out the parallel combination of this ZP2. Its next figure will be something like this. If we don't know it will be inductor or capacitor, it can be represented by the something like this blocks. This is ZP2. This is ZP1 maybe. A parallel combination. Here it will be the J3 that, and here it will be the source with 5 angle 90 degree. This is J4. How much is the parallel combination? This value 10 into minus J4 divided by 10 minus J4. This parallel combination, I will find out its value. I will shift the calculator in the complex mode. Already it is in the complex mode. I will work out this calculation. Means it is 10 into, in bracket, 4i minus 4i minus 4i. I will close the bracket. This multiplication divided by this value in the bracket 10 minus 4i close the bracket is equal to. This value is, this parallel combination is 1.379 means 38. I will take its value. Then shift this value. It is minus 3.448 means 45 J. Is this value ZP? This parallel combination. This is the parallel combination value. This is right. Now here we will find out the current for second case. क्योंकि इसमें current ये current हम निकाला. This is I2. Total current for case 2. Total current for case 2 is 5 angle 90 degree divided by this impedance plus this. Is it right? Means 1.38 minus J 3.45 plus J3, this value. I will find out I2. Now we will convert this value to the complex form first. Now I have to come out of the complex mode because we are interested in the conversion of this value, polar value to the rectangular value. In that case, we can use polar to rectangular conversion. In that case, I am using this rectangular, shift rectangular, this value. First value is a 5, comma. The second value is how much? 90. This is 90. Close the bracket. Put is equal to sign. That will give the real part of this number, which is 0. 0. And then alpha 10 is equal to 5. With 5i or j5. Means it is plus j5. This value, this conversion divided by this value 1.38. This is plus value and this is minus value. This is plus value j3 and this is 3.45. Its resultant value will be minus j 0.45. Is this value? That's why how much is the total current now? I will shift the calculator to the complex mode and we will do this division. 5i divided by bracket start this value 1.38 minus this value 0.45, sorry, 0.45 I will close the bracket is equal to this value will be minus 1.06 amperes. And what is the next part? It's a shift of real imaginary part. That is plus J 3.27. This is the current I2. Where is the I2? This total current I2 we have calculated. We are interested in this current, that is IL2. Now, how is the IL2, this current? I will use the current division rule. I will apply the formula IL2 is equal to, how is the formula? Total current, this is minus 1.06 plus J, this is 3.27. Total current into resistance of the opposite branch, which is minus impedance, divided by impedance of both branches, that is 10 minus J4. Work out this calculation, and with this calculation we will get its value, which is the IL2. Start bracket. This is minus 1.06 plus 3.27 I, close the bracket, into start bracket, this value minus 4I, close bracket, divided by this value, start bracket, 10 minus 4I will close the bracket, is equal to sign. That is 0.98 is the real part. Shift of this will be plus J 0.81 amperes. This is the IL2. Now look at the direction in both cases. In this case, how is the direction of the current? Forward. In this case, how is the direction of the current, which is reverse? That's why the resultant current IL will be IL1 minus IL2, which is equal to, how much is the IL1? This value, otherwise this value, it is 0.41 minus J 0.49. 0.41 minus J 0.49. This value, bracket, minus this value, which is 0.98 plus J 0.81. This is right. I will write this value here. Its answer. Is it right? So here in this case, we can find out its value IL1 minus IL2 or IL2 minus IL1. Both is correct. I will find out this value. Only the difference is the sign. I will take this first value. Bracket start. 0.41. It is 0.41 minus. This is 0.49i close bracket. Then minus sign start bracket and this value. 0.98. This value plus 0.81. 0.81i close bracket is equal to. This is minus 0.57 is the real part, and shift this will be minus J 1.3 amperes. Otherwise, this value will be minus sign को अगर हम common लेते हैं, this 0.57 plus J 1.3 amperes is the answer.